All right, and we're going to wrap up our work with complex numbers by now dividing two complex numbers. So we have complex number 3 plus 6 times I divided by 3 minus 2 times I. So when we are going to divide two complex numbers, we have to use that idea of a complex conjugate. So that's what we're going to do here. So I have the complex number that I want to simplify, or the division of the two complex numbers, 3 plus 6i divided by 3 minus 2i. That's what we want to simplify here. And what I'm going to do is I'm going to multiply the numerator and the denominator by the same number, because you can do that with fractions. If you multiply any fraction by the same number in the numerator and the denominator, it maintains the equality of the fraction. It doesn't change the value of it, but it changes the values of the numerator and the denominator, but the relationship doesn't change. So I'm going to multiply this fraction by the complex conjugate of the denominator. And I'll kind of go over why that's happening here once we see what happens in the end. So got a lot of distribution to do here. So I'm going to multiply 3 plus 6 times I times the quantity 3 plus 2 times I. So I'll do that distribution. I'll do the same thing with the denominator. And by carrying that out, I get these expressions. So this 9 plus 6i plus 18i plus 12i squared comes from the product of these two complex numbers by just distributing. And then the denominator comes from the same thing of multiplying these two complex numbers that are complex conjugates of each other. And we get this expression here. And now there's some simplification that we can do. So in the numerator, I'm going to simplify the 6i plus the 18i, 24i, because they're like terms. This I squared is -1, so I'll change that to -1. And then I do something similar in the denominator. Notice that we have a positive 6i and a negative 6i. These two cancel out because they're opposites. And then this I squared is -1. So you'll notice these are gone. And then the I squared is -1. So what's nice here is now all of a sudden in the denominator, we're going to have a real number, which was that idea of the denominator multiplying by the complex conjugate of the denominator. So carrying out some more simplification here, I'm going to do 12 times -1, which is -12. So this will be, this right here is a -12. 9 minus 12 is -3. The 24i stays put because there's no like terms to combine that. -4 times -1 is +4, and 9 plus 4 is 13. So now we have this expression here, and I'm going to simplify that just a little bit more to -3 over 13 plus 24 over 13i, and you can't see the I there. It's like out of the screen. Let's see if I can move that. Maybe you can see it now. So we have -3 over 13 plus 24 over 13i. So what this thing is right here, this is the quotient of these two complex numbers. If I have to divide two complex numbers, I get this complex number, and this is a complex number in our a plus bi form, where a is -3 over 13, and b, the imaginary part of this, is 24 over 13, which are not nice fractions, but they're still real numbers. And this is the quotient of these two complex numbers by way of multiplying the numerator and the denominator by the complex conjugate. And again, the purpose of that is to eliminate this imaginary or complex number from the denominator. So now we have denominators that are real numbers, and more importantly, we can get it in this form, this complex number form of a plus bi. So that's where this process of taking this division problem and simplifying it into a more standard complex number form.